Dear friends, now let us discuss one very important theorem of integration on the vector function, that is a Stokes theorem. What Stokes theorem says that? Okay, have a look on this. Let S be the surface bounded by a closed simple curve or a simple closed curve. So as usual, the curve is always denoted by C, and if f, it is a vector function, f is a continuously differentiable function, then according to the Stokes theorem, that a line integral over C f dot dr is equal to a double integral over the surface S. This can be written as you know that curl f dot n cap into ds, where n cap is the unit normal vector, as you know that. Or this curl f, instead of curl f, we can rewrite like this also: a line integral over C f dot dr, that can be written as a double integral over S, that means surface integral. The curl f can be written as del cross f also, del cross f and n cap into ds. This is what the Stokes theorem statement. Once again, recall the Stokes theorem here. Let S be the surface bounded by a simple closed curve, and if f is a continuously differentiable function, then a line integral over C f dot dr is equal to a surface integral, that means double integral over S curl f dot n cap ds, or a line integral over C f dot dr is equal to a double integral over the surface del cross f dot n cap into ds. So now what is the procedure? We have to take this one. Okay, here the procedure is, first I have to write down the r vector, that is a vector equation, and then find out the dr vector, and then find out the f dot dr vector. After getting f dot dr, let us find out the first form. That means line integral over C f dot dr. After getting this, find out the RHS, double integral surface del cross f dot n cap into ds. Let us discuss a very beautiful problem associated with this Stokes theorem. Okay, understand the problem. It is very beautiful and little bit lengthy also, but don't worry about that. So the problem is very easy. You can easily manage the problem and the solution. What's the question here? Verify Stokes theorem for the vector. Verify. Have a look on this. Verify Stokes theorem. Verify Stokes theorem for the function. F vector. So and note down, instead of f vector they can take a vector also. Both are same. F vector, that is x square plus y square into I, x square plus y square into I, x square plus y square into I, minus 2xyj, minus 2xyj, taken around the rectangle. Have a look on this. This is very important. Taken around the rectangle bounded by. They are given the boundary condition. Rectangle bounded by x is equal to 0, x is equal to a, and one more condition is there, that is y condition. Y is equal to 0 and y is equal to b. So have a look on this, dear children. The question once again I recall it. verify Stokes theorem for the function f vector is equal to x square plus y square into I minus 2xyj taken around the rectangle bounded by x is equal to 0, x is equal to a, and y is equal to 0 and y is equal to b. So before going to verify the Stokes theorem, let us write down the formula. Let us write down the formula by using Stokes theorem. By using Stokes theorem, what we are going to write here? So we have to write the formula. Stokes theorem verification, a line integral f dot dr over a curve C is equal to a double integral over the surface S. This can be taken as curl f dot n cap into ds. This is a formula. Okay, one by one let us start out. First let us find out the LHS and thereafter you have to sort out the RHS. So before going to verify this, let us write down a rectangle here bounded by x is equal to 0, x is equal to a and x is equal to b. Okay, I can write something here. So this is, as you know, that very simple. So this is x-axis and y-axis. We have to write x is equal to 0, x is equal to a, and y is equal to 0 and y is equal to b. Yeah. Okay, what happens here? Here, this is x is equal to 0. X is equal to 0 is nothing but y-axis. X is equal to a, that is x is equal to a is nothing but a line parallel to y-axis. So this is some a. So this is a line where we get x is equal to a, right? And one more point is that y is equal to 0. Y is equal to 0 represents x-axis, and y is equal to b. Y is equal to b is a line parallel to x-axis. This is y is equal to b. Here we have to write the point of intersection. Let us write down the point of intersection. So what is the point of intersection here? You can take, you can make a rectangle here. Okay. Sorry about this. Okay, I can make a rectangle now. So here I can take x is equal to a here. X is equal to a, and this is y is equal to b. And we have to make this point of intersections here. So here I can take O, origin 0, 0. You can take a. This a can be taken as here along x-axis a, y is 0. And here this is a point B, a comma b. Okay, a comma b is a point. You can take here only b of a comma b, and this is a C point. The C point, the x value is 0, y value is b. The direction is taken like this. This is what. So O to A to B here, and B to C and C to O. It is a direction. We have to verify this. So let us consider the LHS part first. What is the LHS part here? So this is what? F dot dr. First, before going to that, F dot dr, as you know that dr vector is equal to, understand this, dr vector is equal to dxi plus dyj and dzk. Okay, how it is dxi plus dyj plus dzk? As you know that r vector is xi plus yj plus zk. Then dr vector is dxi, dyj and dzk. And what is f vector they are given? F vector is equal to x square plus y square I minus 2xyj. This is what. Find out f dot dr. Okay, f dot dr vector component wise multiplication. Dx into this, I mean x square plus y square into dx plus dy into this is minus 2xy into dy, where k component here is absent, that is equal to 0. So that is f dot dr. Now this is, let it be in one side. I have to find out the LHS part. What is LHS here? A line integral over C f dot dr. So that is equal to, this curve is along OA, AB, BC and CO. This can be written as, this is very very important, a curve is along OA, f dot dr plus a curve is along AB, f dot dr, a cyclic sum, plus a curve is along BC, f dot dr, plus the curve is along CO, written, so f dot dr. Let it be taken as equation number 1. This is a LHS part. So line integral over C f dot dr is equal to along the curve OA plus along the curve AB. Nodi here along the curve OA plus along the curve AB, along the curve BC and along the curve CO. This is the complete cycle. So let us find out one by one. Okay. Now I can rub this concept here. The figure is needed, much needed. So thereafter we can make that f dot dr is this one. Okay. So now the first let us take along. After this one by one, let us start out here. Okay. Now along the curve OA, what happens here? Along the curve OA. So what happens to along OA? This along OA, what is the condition? Y is equal to 0. When y is equal to 0, that implies dy is equal to 0. Am I right? And x varies from where to where? X varies from 0 to a. Right? X varies from 0 to a. Since it is an x-axis, we have to take such things here. So now, okay, now the curve along OA, integral over OA, f dot dr is equal to, this can be taken as along OA 0 to a. Okay. So y is equal to 0, dy is equal to 0. As you know that here I can take f dot dr. This is much needed. F dot dr already know that x square plus y square into dx. In the beginning we made this one. Minus 2xy into dy. Okay. Have a look on this. So when y is equal to 0, this becomes x square dx. X square dx. And y is equal to 0, dy is equal to 0. This entire thing vanishes. Now integration of x square is x cube by 3 from 0 to a. Just apply the upper limit. What happens here? A cube by 3. This is over. A cube by 3. Now let us find out along AB. Okay. Along AB, what happens here? Along AB here, x is equal to a, y is equal to 0 to b. This means along AB the condition is x is equal to line a. That implies dx is equal to 0 and y varies from where to where? Y varies from, why we have to take y varies from? So this is a line parallel to y axis. Y varies from where to where? 0 to b. Am I right here? So now the curve OB, so f dot dr. So this can be written as, so from 0 to b, this is the value of y is equal to 0 to b, x is equal to a, so x is equal to a, this becomes a square plus y square, dx is 0, right? Remaining is minus 2x, x is nothing but a, minus 2ay into dy. Just integrate minus 2a into y is nothing but y square by 2 from 0 to b. Just 2 get cancelled. Minus a, y is b, that becomes b square, minus ab square. So this is what along the curve AB. Now we have to find out along BC. Okay, have a look on this. Along BC, this is a line y is equal to b, which is parallel to x-axis. Y is equal to b, that implies dy is equal to 0. Am I right? And x varies from where to where? So x varies from here to there. X varies from a to 0. A to 0. This is what. So now, so line integral from b to c. So f dot dr. Have a look on this. F dot dr is equal to from where to where? So this is from x varies from where to where? A to 0. Right? So a to 0. Y is equal to b and dy is equal to 0. That become what? So this become, have a look on this. Y is equal to b, x square plus b square, x square plus b square into dx, and dy is equal to 0. This entire thing becomes 0. Then what happens here? Integration of x square is x cube by 3 plus b square is constant, b square into x from b to 0. Sorry, that from a to 0. Just apply the upper limit. What happens to upper limit? So upper limit is 0, 0, that become 0 minus. What happens to lower limit? Lower limit is a cube by 3, a cube by 3 plus, when you put x is equal to a, this become ab square. So ultimately answer is minus a cube by 3 minus ab square. This is along the curve, what is that, OA, AB, BC, and the remaining thing is along the curve CO. It is written of that. Okay. Now how to take that one? How to take that one? So now along, okay, keep that in one side. This is very beautiful problem, very beautiful one. Okay, the next question is, so along CO. Along CO, that is nothing but along CO, what is the condition? X is equal to 0. When x is equal to 0, that implies dx is equal to 0 and y varies from b to 0, right? So since it is y axis, y varies from b to 0, okay, b to 0. So now you have to take this one, now you have to take this one. So line integral over c f dot dr, that is equal to from where to where? So that is y varies from b to 0. Look at the direction, b to 0, CO, b to 0. So here x is equal to 0, then dx is equal to 0, this entire thing becomes 0, minus 2, x is what here? 0. Okay, x is equal to 0, what happens here? The entire thing become what? Okay, that entire thing becomes 0, that is equal to 0. Therefore, equation 1 becomes, as you know that, so equation 1 is a line integral over c f dot dr is equal to, the first thing is along the curve OA f dot dr. Along the curve OA f dot dr is what? Okay, a cube by 3, right? A cube by 3 plus along the curve OA is there, AB. Along the curve AB, the answer is minus AB square plus along the curve BC, the answer is minus A cube by 3 minus AB square plus along the curve CO, the answer is 0. Here A cube by 3 minus A cube by 3 get cancelled. So and this become minus AB square, remaining is, that is equal to minus 2AB square. This is, let it be as equation number 2. This is C f dot dr. Keep in mind that is minus 2ab square is an equation 2, that means LHS part of the Stokes theorem. Now let us find out the RHS part of the Stokes theorem. What is the RHS part? As you know that says that RHS part is a surface integral over S. So f dot, that means curl f dot n cap ds, right? So we have to find out curl f first, very fast. Curl f is nothing but del cross f also, that is taken from the determinant concept. Okay. How to do this, sir? So now I think this one is not necessary right now. It is necessary, figure is right now necessary to find out the LHS part. Okay. Now we have to find out. Have a look on this. Curl f. The curl f is given by determinant of I, J, K. As you know that curl f is nothing but del cross f. That is nothing but dou by dou x, dou by dou y, and dou by dou z. Now write down the f components here, along I, along j, and along k. Along I, what is the component? X square plus y square. Have a look on this. Along j, what is the component? Minus 2xy. Along z, this becomes 0. By expanding determinant, this the quantity become what? 0i because I into this and this. So it is independent. So I into 0 minus j into 0 plus k into, what happens here? K into dou by dou x of this. Dou by dou x of this, that become minus 2x, minus 2y minus dou by dou y of this become 2y. So remaining thing is minus 2y minus 2y minus 4yk. This is the remaining thing. Okay. So this is what correlate. Now we have to take what that correlate dot n cap ds. Let us find out n cap ds. What is n cap ds? As you know that n cap ds is always, have a look on this, n cap ds is always taken like this. So it is from dy dz into I plus, since it is a I component, left the dx and remaining write it. So dy dz I, then what that dz dxj plus what dx dy and k. Now how to find out this curl f dot n cap ds. What happens here? Here only k component is left. Just multiply the k component. So that become minus 4y into dx into dy. This is. Okay, now how to find out the surface integral? So this is we wish to find out. Yes, curl f dot n cap ds. So that is nothing but integral from. So only the remaining thing. First, let us write down the what is our quantity here. Minus 4y into, I already said dy into dx. Okay, now here the first integral here, interior integral is y, exterior integral is x. X is varies from 0 to a, y is varies from 0 to b. Therefore, I can write here, so x is equal to 0 to a and y is equal to 0 to b. What is the remaining thing is minus 4y into dy into dx. So x is equal to 0 to a, integrate that minus 4y square by 2 from 0 to b dx. Okay, this is an y integral. So to 2's that get cancelled, that is equal to x is equal to 0 to a minus, just apply limit, to 2's 2 is remaining, to b square into dx. Now integrate this with respect to x, integration with respect to x, what happens here? So this becomes minus 2b square x from 0 to a. Just apply the upper limit. Minus 2x is ab square. This is equation number 2. Nothing but double integral over surface curl f dot n cap ds. So from 1 and 2 both are same, right? From 1 and 2 LHS is equal to RHS. Since LHS is equal to RHS, Stokes theorem is verified. Stokes theorem is verified. Okay, this is very important problem. Now after this, let us understand the same problem. But with a different boundary condition. So look at the next question, which is most important. Here the very important thing is drawing the curve is very important by using the boundary condition. So boundary condition, they will give that. By using that boundary condition, we have to do the problems here. Okay. First, understand the statements of Stokes theorem. Okay. Now, I am going to write the second problem here. Verify Stokes theorem for the function f vector is equal to x square plus y square is equal to I minus 2xyj taken around the rectangle bounded by x is equal to, this is the extra thing, x is equal to plus or minus a. That means x is equal to plus a and x is equal to minus a, and y is equal to 0 and y is equal to b. Let us write down the figure first. Okay, so this is x-axis and y-axis. Here I can take, here x is equal to plus or minus a, write down x is equal to a. X is equal to minus a. Here write down x is equal to plus a. Okay, x is equal to plus a. So this is from here to here, Then I have to write y is equal to 0. Y is equal to 0 is nothing but this entire x-axis is y is equal to 0. Here also y is equal to 0. Okay, now, so this entire x-axis, on x-axis y is equal to 0. And y is equal to b is nothing but, it is upper part plus b. Therefore, here we have to take y is equal to b. So this is y is equal to b. This is a line parallel to x-axis. Note down the boundary condition here, here, here. I can take this one as O and this one as A, B, C. Okay. So this O is taken as here. What is the O? We have to take it as O is taken as minus A comma 0. Why it is minus A comma 0? This is minus A. Minus A comma 0. A is nothing but what? Where to where? Here the x is plus A comma 0. X is plus A. And here this B is A comma B. And this C can be taken as. So this is a line y is equal to B. Am I right? So the condition what we have to take it as the C condition is, what is the C condition? Here minus A. X coordinate is minus A. Y coordinate is B. This is what. The direction is OA, AB and BC and CO as usual. So now let us write down using Stokes theorem. Stokes theorem. Using Stokes theorem, what I have to write? A line integral over C f dot dr as equal to as double integral over surface. That means surface integral curl f dot n cap ds. As you know that curl f can also be taken as del cross f. Okay. Now let us find out the LHS part. Before going to find out the LHS part, we need f dot dr. Okay. As you know that I can take dr vector is equal to, as you know that r vector is equal to xi plus yj plus zk. Then dr vector is what? Dr vector is dxi plus dyj plus dzk. Okay. Then f vector, what they are given? F vector is x square plus y square into dx minus 2xy into j. We have to make this one f dot dr. So f dot dr, or you can directly write down f dot dr. So I instead of I you can take dx, j, dy you can take. So f dot dr become what? X square plus y square into dx minus 2xy into dy. So here there is no k component in f, therefore that becomes 0. This is what f dot dr. So under this also I am going to write. So f dot dr is equal to, so x square plus y square into dx minus 2xy into dy. This is what. Okay, now let us find out the LHS part here. What is LHS part here? A line integral over C f dot dr. Am I right here? So this f dot dr. This curve is along OA we have to take, AB we have to take, BC we have to take and CO we have to take. This can be taken as, so along OA f dot dr plus along AB f dot dr, along BC f dot dr and along CO, right, f dot dr. So this is let it be as equation number 1. Now we have to find out one by one. I think this is easily understandable. This graph. So x is equal to plus or minus. X is equal to A is nothing but line parallel to y axis from the right side. X is equal to minus A is a line parallel to y axis from the left side. And y is equal to 0 is nothing but it is an x axis. Y is equal to B is a line which is parallel to x axis. That is what. So therefore the curve is from OA, this the closed curve, right? We have to close it. OA, AB, BC and CO. That's why it is a simple closed curve. We have to find out one by one along OA, along AB, along BC and along CO we have to take. So one by one I am going to consider now. Please understand. Okay, what is that, sir? So along OA. So think once again, along OA what happens here? Along OA, it's very simple. It's very simple. Along OA, look at the condition. Along OA, what is the equation? Y is equal to 0. When y is equal to 0, that implies dy is equal to 0. And OA is nothing but x axis. X varies from where to where? Here minus a to plus a. In the previous problem, 0 to a. Because there we are taken from here to here. But here we are taken from here to here. So x varies from where to where? Minus a to plus a. So therefore f dot dr OA along OA is equal to, so where to where? From minus A to A. Here I have to write f dot dr. Y is equal to 0. Y is equal to 0. Dy is equal to 0. So this quantity becomes 0. Here y is equal to 0. This becomes x square into dx is the remaining thing. Sorry, x square into dx. So apply this become x cube by 3 from minus A to A. So by applying this upper limit, a cube by 3 minus of minus a cube by 3, this becomes 2a cube by 3. This is what? 2a cube by 3. And the second one is along AB. Have to take along AB. What is the equation here? X is equal to a condition. Look at that. X is equal to a. X is equal to a. That means dx is equal to 0. So this is a line parallel to y axis. Therefore, y is varies from 0 to b. Y varies from where to where? 0 to b. So therefore, along the curve AB, f dot dr I am going to write. So f dot dr is from where to where? So from 0 to b. X is equal to a. X is equal to a. That means a square plus y square. But dx is 0. Okay. Here minus 2, x is a, minus 2ay into dy. Minus 2ay into dy. This can be written as minus 2a into y integrated is y square by 2 from 0 to b. The answer will be minus 2 to get cancelled. Okay. Y is b square minus ab square. This is what answer. So now along the curve we have to take. Along what that? OA is over, AB is over, now BC. Along BC, what is the condition? Along the BC, the equation is y is equal to b. Y is equal to b. That implies what? dy is equal to 0. Just differentiate this. So b is a constant, derivative is 0. Now this is a line parallel to x-axis. We have to take the A condition. A varies from where to where? A to minus A. Therefore, so that means x varies from minus a to plus a. Okay. Now we have to take along the curve BC. We have to take. So BC f dot dr. Have a look on this. Okay. That is BC. From where to where? So from that is from not from minus a to a. This is from plus a to minus a. Am I right? Plus a to minus a. So plus a to minus a. From here to here we have to take. Here x is equal to a. Here x is equal to minus a. Okay, here y is equal to b, okay. So then it becomes x square plus b square into dx, x square plus b square into dx. What happens to dy? Dy is equal to 0, the entire thing becomes 0. So therefore integrate with respect to x square integration is x cube by 3 plus b square integration is b square x from where to where? A to minus a. Apply the upper limit minus lower limit. So while applying the upper limit, this becomes minus a cube by 3 and b square into minus a, that becomes minus ab square. So by applying the lower limit, upper limit minus lower limit, what happens here? A cube by 3 plus b square into a, nothing but ab square. So after simplifying this, minus a cube by 3 minus a cube by 3, that is equal to minus 2a cube by 3 minus 2a cube by 3 minus ab square minus 2ab square. So this is what along the curve BC, and the remaining thing is along the curve what this one CO. We have to look at the direction. Along CO we have to find out. Okay. After this, the graph is not necessary to make something. Okay. Okay. Along CO, what we have to take here? Along CO, the condition here, what is that? X is equal to minus a. That's what? X is equal to minus a. Then that implies dx is equal to what? 0. This is a line parallel to which axis? Y axis. So y is varies from where to where? B to 0. Look at the y condition. Y varies from where to where? So B to 0. Okay, now have a look on this. So along AB, F dot dr. So that is equal to from where to where? So B to 0. Your x is equal to minus a. Okay, minus a square is a square plus y square. Dx is what? 0. This enough. So minus 2 into x is what? Minus a. Minus 2 into minus a plus a. That becomes 2ay into dy. So 2ay into dy. So integrate with respect to y. This becomes 2a y square by 2. From where to where? B to 0. 2 to get cancelled. So just apply the, no need of applying upper limit because 0. 0 minus b square, that becomes minus ab square. So therefore, so filling in equation 1 becomes, that is the LHS part of the Stokes theorem. So a line integral over C f dot dr, I have to write here along OA plus along AB plus along BC plus along CO, we have to write the value. So what happens here? What is the final answer? So this becomes what? Okay, this becomes 2a cube by 3. 2a cube by 3 is along OA, and along this one become minus AB square, and the remaining thing is minus 2a cube by 3 along BC, minus 2a cube by 3 minus 2ab square, and along CO this become minus AB square. By simplifying this 2a cube by 3 minus 2a cube by 3, so minus AB square minus AB square minus 2ab square, this become minus 4ab square. This is equation number 2. This is the LHS part. So minus 4ab square. This is a line integral over C f dot dr. Now we have to look at the right part. So what is the right part here? So Stokes theorem says that f dot dr is equal to double integral over surface. What has answer? Curl f dot n cap into ds. So now let us find out curl f. Curl f is nothing but del cross f. We have to find out del cross f first. So now no requirement of figure now. Okay. So requirement is only for the LHS part. This figure, not for the RHS part. Okay. Now let us look at this. Minus 4ab square is the LHS part. Okay. Now curl f, instead of curl f you can write del cross f also. Cross product is obtained by determinant of I, j, k. So curl f, the partial derivative, what I have to write here? I dou by dou x, under j dou by dou y, under k dou by dou z. So write down the I component, j component and k component of the f vector. So this is what? X square plus y square, and this become minus 2xy, and this becomes 0. How to do, sir? I into, so dou by dou y of 0, it is a constant 0, minus dou by dou z of this one. Okay, so this minus this. So here there is a upset, this entire thing become constant, derivative is 0. Okay, minus j into, have a look on this, dou by dx of 0 is 0, minus, and this become dou by dou z of this, it is an independent of z, this becomes 0, plus k into what happens here, dou by dou x of minus 2xy, y is constant, minus 2y into derivative of x is 1, minus 2y minus dou by dou y of this, x square becomes 0, it is independent of y, derivative of y square is 2y. What's the remaining thing is 0i minus 0j minus 2y minus 4y into k. This is what curl f. Okay, now what happens here? N cap ds. So n cap ds is as you know that ds is a surface. How can you write? This can be taken up dy dz into I plus dz dx into j plus dx dy into k. Here there is absent of I, j component, thus becomes 0. Remaining thing is k component, multiply this. What happens here? Minus 4y into dx into dy. This is what n cap ds. So now we want curl f, sorry, this one is curl f. n cap ds is that, so we have to make the dot product here. Curl f dot n cap ds is over. So now we have to find out the RHS. So double integral over s. So what is that? Curl f dot n cap ds. Just substitute here. So that is s. Curl f dot n cap ds. This become what? Minus 4y. Instead of dx dy, you can take it as dy dx. Am I right here? So now we have to write the boundary condition. Boundary condition. How to write the boundary condition here? So here inner is y, outer is x. X is varies from where to where. So as you know that x is varies from minus a to plus a. Okay. But y is varies from where to where? 0 to b itself. This is minus 4y into dy into dx. Let us find out the RHS part here. Okay. One by one, let us find out the RHS part. So what happens RHS part here? Outer x is equal to minus a to plus a. Integrate this minus 4y into, minus 4 into, y integral is y square by 2 d, from where to where? 0 to b into dx. To the get cancel and take minus 2x outside, minus 2. So integral from minus a to a, apply upper limit, this become b square into dx. That is equal to minus 2, b square integral is b square x from minus a to plus a. That is equal to minus 2 times of, apply the upper limit, this become ab square minus of minus ab square. So that become minus 2 times of, that to become 2ab square. So that become minus 4ab square. This is equation number 3. So this is what a double integral over surface is curl f dot n cap ds. So from 2 and 3, as you know that LHS is equal to RHS. Therefore, Stokes theorem is verified. So you need to conclude this is verified. Okay, let us discuss a few more results using Stokes theorem in the next segment. Okay, thank you so much.